maximum XOR of two numbers in an array. So we are giving an array nums. So inside the nums, it will be positive numbers. So let's say, it will be 0 and positive numbers, but the maximum number is 2 to the power of 31 minus 1. And also, we need to calculate the result of two numbers if the XOR of these two numbers would be the maximum. So for this example, the maximum is 28 because 5 XOR 25 it is 28. Now let me first go to the whiteboard to explain my solution. After that, I will go back to the code editor to finish the coding. So I'm going to use the first example. So we have numbers from the index 0 to n minus 1. We're going to have numbers 3, 10, 5, 25, 2, and 8. First of all, we might think, what about we just change the numbers to the beta representation? So for the 3, it's going to be 0, 0, 1, 1, and also for other numbers. For 8, it's going to be 0, 1, 0, 0. And also for the other numbers. But we want to calculate the maximum of two numbers. The result is 5 and 25 because XOR of 5 and 25 is going to be 1, 1, 1, and 0, 0, it should be 0, and 1 and 1, it should also be 0. So this is the final result. I think it is 24 if I calculate it right. So this is 16 plus 8 plus 4, I think it's 28. Let's go back to say, it's 28. So it means, it should be like that. But this is actually a brute force solution. It is O(n) squared because we're gonna use two for loops just to check which one is the maximum. But n is 10 to the power of 5, I think. 10 to the power of 5. It means it will be time limit exceeded for Leetcode because for Leetcode normally this time complexity should be 10 to the power of 7, but currently it is 10 to the power of 10. It's much bigger. So it seems we have to use some time complexity should be less than 10 to the power of 7. Or it can be 10 to the power of 7. So this means we can use some bit manipulate to solve the problem. But how should we use the bit manipulate? Because all those numbers are unique. Actually, there's no characteristics we can find to numbers. Because the brute force is really straightforward. But if you look at the numbers, so you're gonna find some regular properties of the numbers. So for example, for the binary representations, so from the left side, so we're gonna call it this is the low bit, and from the right side, so this is the high bit. So I'm gonna call it a high bit. So for the highest bit, if we only consider one bit, for example, we're gonna consider the bit from the right to the left. We first consider the highest bit. Why? Because we want to calculate the maximum of two numbers, XOR of two numbers. So we're gonna consider the highest bit first. So inside the highest bit, inside these numbers, what if we just choose two numbers? For example, this 0 and this 1. Because 0 XOR 1, it should be 1. It means we can find some pairs. If we find a 0 and 1 pair, so for the highest bit, it means we have a 1. If we can use this solution to choose the bit one by one and try to check if we can find the maximum number, maybe we can find a solution. So we're gonna prepare a mask, and we're gonna use the mask to check the numbers. So what's gonna be the mask? So the mask, first, the mask will be like, if we have 5 bits, for example, the mask will be like this. We're gonna choose the highest bit. So this is the mask. So why we're gonna use this mask? Because our answer is possible of this mask. It definitely, it is not, if we define a mask, so the result can be this array, can be this mask, or it cannot be this mask. It always depended on inside the bit inside this highest bit, if this is the first highest bit, if there's a 0 and 1, so this it means for the result, it must have this highest bit. But for others, we are not sure. Yeah. So currently, I'm not going to talk about how to calculate the 0 and 1s just in O1 time. So this means in total it will be ON. But let's just check if we can have a result of 1 and all others. So all others currently we are not sure, but definitely for the highest bit it's gonna be 1. Why it is 1? Because inside the highest bit there are gonna be two numbers, 0 and 1. So this means we can use the mask to check the numbers. If we use a mask like 1, 0, 0, 0, and 0, so for the mask, if 0, we're gonna use 0 and 1. Yeah, so if 0 bit and this 1, it's gonna be the 1. Yeah, because we are only going to check the highest bit. So this is why we're gonna use a mask like this, because this number XOR, this number and this number and any kind of the numbers. For all other bit, it will always be 0. But for this highest bit, it always depended on inside. It's gonna be 0 or 1. If it is a 0, definitely we have a number like this. So for the highest bit, we have a number like this. And also, let's check, do we have a highest number of 0? Yes, we do, because inside there are so many zeros. Yeah, and for all other numbers, if we use the add, so this number add a mask. Yeah, so it's gonna be 0 and 0. Yeah, so we have numbers like this. If this number and this number, we can use XOR. If XOR of those two numbers, definitely we can get the highest bit. Yeah. So this is the first bit we get for the highest bit. And then we're gonna check the second bit. So for the mask, it will be updated from 1 0 to 1 1 0 0 0. And then we're gonna check the next bit. So for the next bit, how we gonna check? Yeah, it's also the same. So for example, inside we just want to find if we inside find a 0 0 for the highest bit, and for others we don't need to take care. Yeah. So what about another number? It must be 1 1, because 0 0 x on 1 1, we're gonna get the 1. We're gonna get the highest result 1 1 1. So the high result will be 1 1. Yeah, x x x. We don't know yet. Yeah. So for the second number, do we have that kind of number? Yes, 0 0 and 1 1. Yeah. Now we're gonna choose the third highest bit. So the third highest bit, maybe it is this number 1 1 0 and 0 0 1. It means it is okay. So it means we have a result of 1 1. And yeah, let's check what is the result. So we're gonna have a result of 1 1 1, because this 1 x on this 0, it must be 1. Yeah. Now let's check this bit, the fourth highest bit. So this one. Yeah. So for this bit inside here, it's gonna be 0. So this is a 0. But for this number, it is a 0. We cannot find a 1. Yeah, of course, others have 1s, but all the highest bit is 0, 0, 1, and 0. It's not okay. Yeah, because we always wanted to have the highest number, because already the numbers has already converted to 1 1 1 with this 0. It is here, and 1 1 1 with this 0. Yeah, so it means we cannot find. Yeah, we cannot find a highest. We can, when we find a 0, when we meet a 0, we cannot find a 1. So it means for this bit, it must be 0. Yeah. Now let's go to the last bit. So for the last bit, this is 1. Actually, if inside we find a 1, we want to find a 0, but there's no 0 for this bit. So what are we gonna do? So we're gonna still have a 0. Yeah. So this is the final result. It is 28. Now let's check how can we use a data structure, use O1 time, to find two numbers, find two numbers if the numbers x with x on. Yeah, let me use yeah, we can find two numbers, use x with x on y equal to the maximum number result. How can we find those two numbers? Yeah, and for the bit manipulation, this is x on. We can use the bit manipulation to calculate. For example, we can use x on x. Yeah, we can use x with x on y and x on y. So from the left side, it's gonna still be the x, but for the right side, because y x on y it is a 0, x on 0 it is still x, so it's gonna be the result with x on y. Yeah, so this means if we want to calculate the maximum of x and y, yeah, if we know the result, so it will be two numbers inside the set. So if x is inside the set, yeah, let me check. So this is a, yeah, so we're gonna enumerate y, for example. So if y, we find a y, so for the next number it must be result x on y. If we find a result with x on y still inside the set, yeah, so it means we find the maximum of two x ons of x on y. Yeah, because we're gonna use a hash set to represent two numbers. So basically here it is the two sum. So if we find one number, yeah, because we want to calculate x and x on y to be the maximum. So the maximum is the result. So x equal to the result x on y. So it means if we find one number inside the set, so for the next number, if this one result x on y is inside the set because we're gonna enumerate y. So it means we find the result. So what are we gonna do? So we're gonna update the result. Yeah. So the result, how it can be updated. Yeah. So I'm gonna use a temporary variable answer to update the result. Yeah, because if I find a result, so my answer will be, yeah. So my result should be equal to the answer, and this answer can be this one. Yeah, if I find a maximum, maybe next one it is 1, so I'm gonna update the result. Now let me go back to the code editor to finish the coding. So as I said, I'm gonna prepare a mask and result. So the mask and result would be start from 0. Finally, I'm gonna return the result, and then we're gonna use a bit manipulation to check the mask from the highest bit to the lowest bit for I in range. Yeah, because there is only 31 bit. Yeah, so inside I'm gonna use a 31. I can also use a 32. It doesn't matter. Yeah, let's try to use a 32. Yeah, it doesn't matter. Let me use 32. Yeah, because 32 always included this number. It's always bigger than 2 to the power of 31 minus 1. Yeah, minus 1 and minus 1. Now we're gonna prepare the mask. Yeah, so the mask will be some numbers. Yeah, let me just finish writing the mask. Yeah, so the mask will be first like 100 and 110. It will be the numbers like that. So we can use XOR operation to check the mask. So the mask would be the mask XOR. I should be 1 should be shift left. How many bits? It should be I. Yeah. So this means that the highest bit will always be a mask. The highest bit will always be a 1. Yeah. So actually, inside it will be some numbers like 100, and for the next mask it will be 110. Why? Because we always want to choose the maximum result. Yeah. So we're gonna prepare the mask like this. And I also prepare a temporary answer, and this answer cannot be the mask. Yeah, because the mask is just a mask, but the result can be smaller than this mask. Yeah, for example, the mask can be something like this, but the result can never be like this because we are not sure if the answer, the result, yeah, is this number yet. So the answer should be the result. Yeah, so for example, if we already know the result, currently the result is 0. So it's gonna be the result or 1 shifted left to the I bit. Yeah, so this means from the beginning, so this is 0, and the answer is still equal to the mask. Yeah, because 1 shifted 32 bit to the left. So this means currently the answer is equal to the mask. But for the result, we are not going to resign the result to answer, the answer to the result because we are not sure yet. Yeah, because we have to check if we find a result, if we find a possible if we find a possible temporary answer, so we're gonna give it to result. Yeah. Now I'm going to basically use the two sum to solve the problem. Yeah. Now I'm going to prepare a set because we need to use our hash set. And then let me check. So yeah, I'm gonna check all the numbers inside the nums. Yeah, because for the numbers, while we are using the XOR, we always compare with the highest bit. So we're gonna use a bit manipulation for here. So the n should end equal to the let me to the mask. This means from here, while we are checking the numbers, for example, for the first highest bit, we're gonna only check this highest bit. We don't need it, for example, 111. We only check this bit. We don't need to check after that. Yeah. So this is why we're gonna use mask. We only choose the highest bit with the mask. Yeah. Now we're gonna check this. We're gonna check this number n. So if the highest bit, it can be 1 bit or 2 bit. It can be several bit, and for the lowest bit, it will always be 0. So if this n is inside the set, so we are sure we find a result. This is not n. I think this is n with if n XOR the answers. Why? Because we currently the answers is the maximum, and the maximum is used to result with the XOR of 1 shifted to I bits for the to the left side, and we're gonna always to use this n with XOR answers because this is the y and n is x. So we want to use x XOR y to be the answer. So if this n XOR answer inside the set, it means we already find x and y. Already find two numbers. It must be the maximum. So we're gonna update the result should be the answers. And if we find an answer, we're gonna break it. So we're gonna break it and check the next bit because we don't need to check all others. Because the answer will always be the same. You don't need to check the answers every time if you already found one. Now, I'm gonna just need to add the numbers inside the set. So the numbers will still be this n. Actually this n is not inside the nums. It has already been calculated with the mask. because actually we are not going to add the numbers inside the nums, otherwise it will be O(n) squared time. So this is why it is still O(n) time. And here is 32 times n, so the time complexity will be 32n. Yeah. Finally, we're gonna return the result. Yeah, let me check just if everything is okay. Because here we're gonna prepare all this mask, and this mask are for the maximum numbers. So this is why we're gonna always prepare the highest bit, and then with the second highest bit and first highest bit, and then all others to be 1. But the answers can never be the mask. So the answers actually it's gonna be the result with XOR. So for example, from here we calculated the result, and here we get we're gonna update the answers. So it will always depended on the result. Yeah, so for some time, if the result is not updated, what it's gonna be? Yeah, so normally for the normal cases, the answers should be like this: 100, 1100, and 11100. But for some situations, there will be no update for this. For the result. If the result is not updated, so result XOR with this one, it's gonna be something like this. It's gonna be 0, 0. Yeah. And for the next number, it can still be 0 and 0. Yeah, because if we didn't find two numbers inside, if it is not bigger than our expected mask, so we're gonna not update the answers. Yeah. If we didn't update the answers, so the result didn't update yet. We still did not get the maximum numbers. Yeah. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, I got a 2 result, but basically it's the same. As you can see, it passed and it's pretty fast. Let's just submit it again to check if it is okay. Yeah, as you can see, it's okay, and the time complexity is 32 times n. And now let me just go back to the whiteboard once again to explain a little bit, and then let's finish this video. I think it must be too long. And first of all, we're gonna transform the numbers into the bit representation, and then we're gonna check the highest bit to the lowest bit because we want to calculate the maximum XOR of two numbers. And for the XOR of two numbers, we're gonna use the two-sum method. We're gonna use a hash set. So if the two numbers, if this x, if a y and result with x with XOR y inside the result, it means we've already found the final answer. So we're gonna update the result. Thank you for